Well, howdy there, Internet people. Well, Al couldn't make it today, so I'm going to run the meeting, and my guess is no one else is going to show up. So I'll go through and do a demo of a couple of things I've been working on here. So let me come over to my other computer here. Share the screen, entire screen, and allow. And how do I minimize this? Okay, so I've been playing with several things. I think last week I was talking about the TurtleBot 3 demo that's part of, if you go to ROS 2 navigation, it says, one of the first things says install, and it will load up it loads up all the stuff to run a Gazebo simulator with RVIZ in using the TurtleBot 3 world. And that loads fairly easily. And I'm currently running a laptop with Ubuntu 2004 and ROS Foxy for the ROS 2 stuff. And if you just follow the instructions, it seems to come up and starts up fairly well. And there weren't a lot of gotchas in there. And I was able to drive that around. And I don't remember if I demoed that last week or not. So then I moved on. I was noticing when I thought, okay, I'll drop my vehicle, my vehicle back here. Here, let me turn off the screen sharing for a second here. So my little vehicle back here is the one that I'm running here, and I wanted to put that into. I want to get that into ROS 2. I've currently got that running in ROS 1, which is some images I had. Let me see if I can pull up an image here. I don't remember how I did this now. Images. Well, maybe I'll find it on, let's see if we can find it on Slack here. Random. Yeah, I should have thought this ahead of time that I wanted to do this, so I wouldn't have to go digging for it here. Yeah, I think I'm getting close here. This one I want. So let me see, share screen, screen 1. And see, how do I make this bigger? Yeah, maybe I don't. Anyway, so this is, I was played with this. This is my physical vehicle in the upper right-hand corner. And then down below, let's see what screen am I on this one. So this one down here is the Gazebo model in ROS 1. And this just shows I've got the vehicle down at the bottom. It's got 4 wheels and just a flat plane for the chassis. And then it's got the 2 white cylinders are my 2 GPS antennas. And the little red thing on there is the IMU. And then the blue thing is the SICK LiDAR. It's the LMS 200, like everybody used to use back in the old days. Let's see if I say zoom in. So that I'm able to load that into ROS 1 and drive that around. And then the other one was, let's see how to close this. In fact, this was an image of it driving around here. And so this is on the right. This is the vehicle in Gazebo, and then on the left is the RVIZ. As I started here, and I was basically driving to 4 points, and it goes from this point out to this point, and it curves, so it hits the. Since it's using the TEB planner, it actually tries to hit the destination at the angle you tell it. So it's kind of forming a square, but it's got rounded corners on it because of the turning radius that I've specified on the vehicle. So let me back out one here. And then I modified it so I could go in and easily change all the parameters. Come on, scroll. There we go. And I got one more picture I zoomed by here. And I'm looking at the Slack channel right now is what this stuff is. So this is, after I got it done, this is the vehicle with Owl's lawn tractor values put into it. So it's got the bigger tires and the longer wheelbase. And I'll just zoom view in the, and here's, as I told Al, here's a picture of his lawn tractor with him standing next to it. And let's see if I can just say next. Okay, this is yeah, this isn't working real well. Anyway, this is the this is just a side view of that same thing. So it's got the larger wheels, and you can see my vehicle is only this big. So it comes out, the front of my vehicle is right here where the LiDAR is mounted on the front of mine. And see, his is almost twice as long as mine is from front to back. And then his is also wider than mine was. And he's got these big monster tires on the back of his. And mine just has the little skinny tires on it. So anyway, I did all that in ROS 1. So then I wanted to pull that into something else. So I was looking at the turtle, I was going to put it in the TurtleBot stuff. And when I started looking at that, when I started looking at the TurtleBot stuff, I noticed that he had a separate model for Gazebo and a separate model that was his URDF file. And I hadn't really thought about this stuff before, but in the in ROS 1, I have a single URDF file. And I'm able to load that directly into Gazebo, and it builds my model, and I can do whatever I want with that. And then it also, the URDF feeds into the robot state publisher, and that parses it and pulls up all your static links. So it says, say GPS to base link, it gives you that one. It gives you the LiDAR to base link and all the pieces that are on there. It generates all that and publishes those as transforms. And the other thing it does, it puts out a topic called robot description. So if you go into RVIZ and say display robot description, then you magically, your vehicle model shows up in Gazebo and you can see it there. So that's it. After I thought about it, that's the way it seems to be working. But now in the TurtleBot 3 stuff, they had a separate model that they're loading into Gazebo. And it not only is it a separate model, it's an SDF format as opposed to URDF format. And so it's basically saying, here's the model and here's the sensors. And then the one, the URDF that gets used in RVIZ, it didn't have quite as much stuff there because it's not trying to generate, say, information for the sensors. So anyway, the point was, that's not the way I wanted it to work. I wanted to be able to put a single URDF model into both Gazebo and into RVIZ through the robot state publisher. So I got the TurtleBot stuff TurtleBot 3 world to run, and it does indeed drive around. But then I thought, well, there's got to be another way that's closer to what I want. So I went out and looked at the Lino Robot 2 project, which is the original Lino robot, was done for ROS 1, and that's one that has all the you can tell it, do you want a 2-wheel drive or a 4-wheel drive, which is really, I think, a skid steer. And then he has one that's a Ackermann robot, so it's got the Ackermann wheels, so you can drive forward and backwards or drive straight sideways. You can rotate in place or whatever you want with that. And he's got on the version 2, he has information to build physical models. So you can build a physical robot. He gives you instructions how to do that. And then on the simulator, you can tell it which type you have, and you can load it into Gazebo and drive it around. And I started looking through that code, and he is indeed taking a single URDF file and loading that directly into Gazebo. And then he's also running it through the other path to get to RVIZ. So I thought, well, I'll go look at that and see if I can get that to work. So I loaded up the Lino Robot 2 stuff, and let's see, let's go to, I'll go to the other screen here. Entire screen, allow. Okay, it seems to be working. Okay, so on here, I've got, I think it's set up right now to load the original stuff right out of the box. So I'll start this one up, and this will start up Gazebo and put the model into it so we can see it. In fact, I think once it does this, I think I can actually drive it. So we'll start this up. And then here in the background, this is the world that comes with Lino robots. So it's just got a playground in the middle. It's got some walls around the outside and a few trees. And something I found interesting, this tree in the back has big tree roots sticking out that the LiDAR doesn't see. So if you're not paying attention, you'll bang into those and that'll cause problems. So anyway, here's the robot. It's just a little tiny 2-wheel drive with 2 caster wheels. And this red thing I think is a camera. And then the green thing at the top is, which is which here? One's a camera and one's a LiDAR. Yeah, so I think at the top one is a LiDAR. It's just a planar, flat plane LiDAR, and the bottom one is some kind of a fancy 3D. It works as a regular camera, and it's like a point cloud camera. And if I get real ambitious here, I can show you that too. So let me make this a little bit smaller. So I'll stash that over here. And now we start up the next. It's hiding back here. This one will start up RVIZ, and it starts up the SLAM mapping at the same time. So I'll start that so you can see what that looks like. So it comes up looking like this. And let's see, how do I move it like this? So right here, my robot's right in the middle. And on the initial scans, you can see it's already, the white dots are the mapping that's starting to fill in. And I think I can rotate like this. So here's the robot model, how it shows up in RVIZ. If I turn off the transforms for a second, it's not quite as cluttered. So there is the vehicle. And then in, let's see, how can I do this? Anyway, so I bring it around like this. So here's your 2 drive wheels, the blue wheels, that's got the 2 cast wheels. This, I believe, is the camera, and this up here is the LiDAR. And if we look at it in RVIZ, that's great. Where did it go? I'm totally lost now. I may give up on this for a second here. Yeah, that's not. Anyway, the model looks basically the same whether you look at it in Gazebo or in RVIZ. So let me back out here, and we do this. That's what I'm trying to do. So anyway, it's a little hard to see right now, but all these objects out here, this is what the LiDAR can see right now. So it can see a wall here, and there's a couple of wall pieces here. This is the big tree that's got the tree roots you don't want to get too close to. And there's along the edges here, there's more wall sections here. So if I drive it, let me grab my joystick. And I just have one of these, I think it's a Logitech. Yeah, it's a Logitech dual action, whatever that is. And I had to screw around with that because I couldn't get I had to add a parameter in the launch file. And last time I was pointing out that in ROS 2, they've switched launch files from the XML format into Python format. So you now got Python scripts that you write. And to me, they make no sense when I look at it. And the more I dig through it, it does get better to the point where I can kind of figure it out. But the problem is the joystick they're using, it would default to JS0. But on all of my laptops, JS0 is the accelerometer built into the laptop, so it knows when you drop it is what that's for. So JS0 is already taken up, so I had to get it to switch to JS1. So I had to figure out how to add parameters to it, and I tried various things. I spent hours on that. I think finally what happened was that I got it down to the format I thought it should be, and I went back to the ROS 2 documentation for launch files. And down at the bottom says, here's how you add parameters. I had it exactly the way they had it. At that point, I think I went back and did a rebuild, and magically it started working. So now my joystick works. So let me fire up my joystick here, and See, as the robot starts moving there, in the lower left-hand corner, this is the camera that that's on the front. That's the simulated camera, the little red thing on there. So that when it's driving around, that's what you can see. So if I rotate, you can see I can point at things and say I just want to drive out towards that tree out there. So if we look at the world and say, where's that tree? Again, this is hard to do. There's that tree out there in front of me. So we've got a straight path going out that way. So if I just start, every time I move, see the map starts filling in a little more as I can see objects out there. So as I start driving that way, I'm driving towards the tree. I see the map starts filling in. So you can drive around the whole area and it'll eventually fill the map in completely. And then there's another command that will save the map. So let me go to the third launch file. And this one will bring up navigation so we can actually drive and map at the same time. So with any luck, this is going to work. So I think that's up and running. So now we can come here and we can say, do it up the top. You say 2D goal pose. And I can come in here and say, I want to drive to this point here. So we go look at that. So it just draws your global path to get there. If you look real close, I've got it turned on for the, there's a little green feeler about 1/2 meter long sticking out in front. And that's your local path as it drives around. So it gets there, and then the window back here says reach the goal. So we'll go back here and just put in another goal down here. And now it's going to do this to me. But for some reason, it doesn't take it every time, and I don't know why. So there it worked that time. But you can see the little, maybe you can see the little green thing on there saying that's the local path. It's moved maybe 1/2 meter out in front of it, saying that's where it's going to drive to try to follow that big path that we gave it. So again, we can just come down here. Another interesting thing is it tries to not drive through the unexplored area. So this area out here, the dark gray, has not been explored yet. So it's just like back in ROS 1. This is the way it's always worked. But you come down here and say, okay, I want to drive to this point. Now what it'll do is, so you can see it's trying to plan through the white area. As it gets closer, this will fill in. And back here, you notice as this is running, see every time this clicks one time, it's replanning like once a second or so. So when it gets out here, it's going to fill in some of the stuff and probably then go directly towards it. We'll see what it does here. See, now it's changing the path, and it's say, okay, I'm getting brave. I'm going to go out in the gray area. And as the white stuff fills in, then it'll drive right through there. It won't care about that stuff. So anyway, that's the Lino Robot 2. Just a short description of that. And when you're all done, you can save this as maps. You get the, anything that's showing up here. These will be black in the map. And I haven't actually done, well, over here on this side, you can see the map's going to look like it's going to be dark gray where it hasn't seen. The white stuff is, or I'll call it light gray, is where it has seen and there's no obstacles. And then along here, there's a black. It actually makes the wall is black out there. And that's just the way the mapping has always worked. That's the way it works in ROS 1 too. So now let's see, so one other thing you can do is if I save the map and shut it down and then don't run the slam part, I can just say navigation. Then I can just, click on the map and drive wherever I want to. Again, just like ROS 1 always did. So let's shut this down. And I'm going to, let's see, close these down. Close that down. Terminal. nano.bash rc. So in Lino robots, to change which vehicle you're running, you have to specify an environment variable. So we come down here and down at the bottom. So the base equals 2WD is two-wheel drive. And then I added, because I wedged my code into here, so I've got one called ACK for Ackermann. And I can't remember if Ackermann is A-C-K or A-K-E-R. So I may have it spelled wrong. I might have to fix that. So anyways, do that and say save that and exit out of there. And then just to make sure, I like to close it down completely and restart it. And so when I restart it, it starts a fresh copy of bash RC. And somebody might say, well, what's this crap at the top? Well, I've simply aliased some commands. So I can say, instead of typing out the thing history pipe to grep and then put what I'm looking for, I can just say HSpace, LA, do that much, and it'll find anything as a launch file. So that's what those things are at the top. I just put those in so I can just find a quick way to do that. I think the other one's like if I wanted a PS-EF, I can do that. So anyway, I come in here, and the first thing you have to do is rebuild everything. And I see ROS2 is real touchy about, you have to rebuild everything. Anytime you make any change, you have to rebuild it. Possibly if I say a colcon build, there's something called --symlink-install. I think what that does, instead of copying all the files to the install directory every time, it just puts a link back to it. So I think that I need to play with that. That way, I think I can change my text files, and when I run it, I don't have to recompile every time like I'm about to do here. And then just simply will rebuild. And then if it's successful, it sources the install setup. And the reason that this happens when you run, okay. So you don't want to run it from back under ROS1. If you would say cat can build or cat can make, you had to be in your workspace, or it would complain and wouldn't run. Well, this one's running it out in the wrong directory, and I don't know how to get around that. So I'll say, go to my real directory. I'll run it again, and then it should come up fairly quickly. So it compiled everything, and it copies all my text files into the install directory. So now I've got, basically, I've created the one for my Ackermann now. So let me say, just run it again and see if with any luck, this will work. Gazebo launch. I think I want this one. So it's the same world, but now I've got my robot in here. So there's my robot sitting there, my four-wheel Ackermann steered robot. And if I do this, I can drive it backwards and forwards. And it turns out another thing I did here on the ROS1 stuff, it has an external Python script, and that is called Ackermann controller. And it will subscribe to an Ackermann message and generate all the values to turn the wheels and to turn the steering. And so the Ackermann control Python script talks directly to Gazebo and says moves the joints in Gazebo, is how that one worked. And then I noticed, I stumbled on a thing, you can get an actual Gazebo plugin for Ackermann control, but it only works with ROS2. So now I've got ROS2 here, and I loaded that thing in. And when I tried to run it, it came up. First it said, oh, I can't find any of your joints. So yeah, I had to change the left wheel, whatever the left wheel's called. I had to put the correct name for my model and go down the line and do all four wheels that way. And now for the steering, I guess for the steering worked the same way. So I got a left steering and a right steering. I just had to put in the correct joint names that's in my Gazebo model. But it had an extra one that is called steering wheel. And if I didn't specify that, it wouldn't work. And I finally dug through their code and their launch file, or their URDF file, and it looks like it's just a cosmetic thing. And this is originally written, they've got a Prius car that it makes a really nice looking car, because that's a nice rendered model and everything. And it goes, you can use it with this particular plugin. And I think it just, if you look through the windshield of your car, it's going to have a steering wheel that turns as you make this stuff run. So I had to define a steering wheel. So I just stuck this on here. Let's see, how do you do this? Like this. So it's just a flat thing. I had a round one, but I couldn't tell if it was turning, so I made it square. I just stuck it on there somewhere just because it has to have something to talk to. I could probably make that invisible and you wouldn't see it. But the point is, if I do this, and if I turn my joystick to turn the wheels, you can see the steering wheel turns. And that kept it happy. But now the problem is, as I turn this, so there, we'll zoom in some more, see really get the effect here. Let's see if I do like this. No, like that. Like that. So as I turn it one way or the other, see that turns, and the front wheels are kind of wonky. Right there, they seem to be turning okay. But I get out here and then they don't necessarily, they don't turn smoothly as I'm doing this. If I turn it the other way, what's it do? And see how they kind of just act. All of a sudden they jump from one point to another. Now the biggest problem is that if I do that, say I turn somewhat this direction, and see they acted funny there. If I try to drive forward, then they immediately turn back and go the other direction. So there's something goofy there. It's either the way I've got things scaled or something in that Ackermann plugin itself needs to be fixed. And I think I decided that if when I was looking at it, that it's subscribing to a command velocity, which would put out a rotational velocity command or a rotational velocity value, yet the steering wants an angle, not a rotational velocity. And I don't think anybody made that translation in that plugin. So I'm going to have to go look at that and see if I can get that to work. So I'm at the point now where I can get the vehicle in my model here. And theoretically, if I'd fire up all the, well, no, I was going to say if I'd fire up all the mapping and navigation stuff, that I could create a map with this, but I don't have any sensors on this right now. And I don't know if I can just grab the sensors from my ROS1 model and drop in here, or the Lino robot has a bunch of sensors defined. So I could just grab the same ones that are on the little tiny model. So I could drop on that camera that he's got. I could drop on that LiDAR, and I don't think he has a GPS. Maybe he does, but I'll have to see. It could be the ROS1 sensors for the Gazebo URDF will drop right in and work, but I haven't tried that yet. I was lucky to get to this point yesterday, just before the Home Brew Robotics meeting last night. I got to the point, but if you notice that it's also drifting around. See, it's slowly driving forward right now, and I don't know why it's doing that either. So that's something else I have to track down. So anyway, just before the meeting last night, I got to the point where I could get the vehicle loaded in, but I couldn't get it to move. And so then after the meeting, I went through and did all this stuff and got it to actually move on its own. And at the Home Brew Robotics meeting last night, the guy from Lino Robots was on, and most of the presentation was him talking about it, basically just going through his wiki and talking about it, and then going to the other GitHub site that tells you how to build the vehicles. So that was on there, and that I believe they were recording it, so that should show up on the Home Brew Robotics YouTube page within a few days to a week or two. So when that shows up, I'll let you know about that. So at this point, I've got the vehicle in there. I got to figure out why the steering doesn't work. I think the other thing is I'll have to go look at it, but I think their thing is defined expecting all 4 tires to be the same diameter. And since I purposely made my tires, yeah, that's handy. Purposely made my front tires smaller than my back tires, just to mimic the big tractors and a lawn tractor. So you can see there, my front tires are smaller than the back tires. So I have to look at that too, and I might have to modify it for that to get that to work. So that's kind of where I'm at with that. And somebody's gonna say, well, why are you using ROS2? Well, number one, everything's switching to ROS2. Secondly, if you want to use the new navigation stack, the navigation 2, you have to go to either go to ROS2 or get ROS1 and ROS2 to talk to each other. And I tried that, I couldn't make that work. And I'm not quite sure why. So at this point, if I can get most of the stuff to run in ROS2, and then any sensors that I don't have, like say, for instance, my SICK LiDAR will not run in ROS2, and I don't know if I have any chance of getting it to run in ROS2. So I could keep that in ROS1 and just send the scan data across to ROS2 for that. And I think my communication node right now is written for ROS1, but it might not be that hard to change over. So that's kind of the that's my progress at the moment. I've been playing with that, and Hopefully I'll get to the point where I can get that fixed. And let's see, how do I stop my sharing here again? Do this, do this, do this. Oh, so another thing, as I go through this, you know, I look at this and the stuff in ROS2 seems to make no sense at all, because I think I just mentioned earlier that I had said that ROS2, they switched the launch files from the, what do you call it, the XML format to a Python format. And then I started finding out, no, it turns out, I think you can still use the XML format. It's just that everybody prefers to go to the Python format. But even if you switch over from ROS1 to ROS2 using the XML format, you still have, there's various things that you have to change that they seem to have basically the same statements, but a field in there instead of, I can't remember what it was, but you have to change the, whatever word was, or you have to change the word to exec now. So theoretically, you could still run the XML launch files, but you have to modify those. And then I'm finding it very hard to track anything down, because I run into a problem and I go search for it, and I can't think what to search for, what to call it. And so I have a lot of problems with that. And then the same problem I have with all documentation these days, you know, if I know exactly what I'm looking for, if I go back to the official ROS2 documentation, find the sections, say for instance, topics, and if I want to look to do something with topics, and which I'll get to, I'll bring it up right now. If I do a ROS topic, now you have to say ROS2 space topic space list instead of ROS topic list, and that'll give you the list of all the things that are running. So if I say ROS2 space topic space echo space slash ODOM, you know, I expect to get my odometry message where you've got, you know, got this block here saying here's your XYZ location, and then there'll be like a big long line here. It's your covariance, and depending on your screen size, it'll wrap around. So maybe 2 lines, and then another block of stuff is this is your twist information. So again, it gives you like XYZ, pitch roll, yaw type stuff, and then another covariance below that. Well, when I run this under ROS2, they've expanded the covariance out, so each element is on its own line. So instead of getting, I think you know, you pull up a screen, it looks like this. It's got like 32 lines in a standard odometry message, which will comfortably fit on a terminal screen. But in ROS2, when I run it, it spreads everything out. Now it takes like 70 to 80 lines to display this thing. And that just fits simply, your screen's this big, but the display is this big, and it just will not fit on the screen. And so well, how do I fix that? So, you know, you go out to the documentation, they say, oh, well, run a ROS topic echo on, say, command velocity, and it's got like 4 lines of stuff. So they always pick the simplest thing that doesn't address what you really need, and that's the way they write all their tutorials and all their documentation. That, you know, yes, it's a problem, but they're not going to tell you right there. So I figured it's either somebody just thought, well, it'd be cute to do that because it's easier if you want to pipe that into something else to have each element on a separate line. Or somebody just liked that format, so, oh, I like that way, we'll force everybody to do that. Or it could be there's an environment variable that says, you know, the don't F me environment variable, you set that, and then it goes back to the old format. And I thought there might be like a command line parameter, but I can't find anything saying that you put this on to not, you know, to not expand everything out. So that's some of my aggravation, just trying to track that stuff down and figure out what to do with that. And what are my other things? And then the stuff on Gazebo that I'm going through, trying to figure out how to get, you know, can I take it from ROS1 and drop it right into ROS2? Well, it turns out most of my URDF file did work. I think there's a couple little changes I had to make. And then they have the Gazebo plugins. They used to have one, I think it was called Gazebo ROS plugin or something, that worked under ROS1. And now they said, well, when we went to ROS2, there's a lot of bloat in that. So it's simply, you know, like 10 or 20 times more stuff that you need. So now I decided to break that up into separate little plugins. So now you got to go try to figure out which one of those plugins do you want. And so far I haven't found a page that said, this is what we've got. I found a page saying, this is what I'm proposing that we do. And, you know, they'd say, well, here's stuff for the model. We'll put it into this this plugin, here's stuff for the communication, we'll put it into this plugin, and so forth, right down the line. But that doesn't say what they actually went to, and I can't find a new page saying this is how you look up what we really need here. So that's been aggravating. I've been fighting with that. Also, either the last meeting or the meeting before, I was saying that somebody wanted a Gazebo plugin that would simulate a radio direction finder. And I said, oh, that's simple. You just go into Gazebo and say, what's the robot position? And go into Gazebo and say, where's your fake transmitter located? And you take those two values, you take the delta X and delta Y, and you figure out the vector between those two. So you take to get the distance, you do the square root of X squared plus Y squared. That'll give you the distance. And then the angle is like arctangent 2 of Y over X, I think is what it is. And then you can just publish those numbers out. So I wrote this up and sent it to this guy that wanted it. And then later I thought, this may not work under ROS2. And when I looked at it, no, it's got no chance of working under ROS2. So what you'd have to do, you have to go to the tutorials and say, how do you write a Python node in ROS2? So that'll give me the basic framework of my Python script. And then it says the one called write a Python publisher. So if I take a couple lines out of that, that will show me how to publish from the new ROS2 node. And then the biggest trick is trying to talk to Gazebo, because in the original method under ROS1, you'd say ROS service, I think you say ROS service list, and it would show you all the services that are available. So you scroll down, it says Gazebo this, Gazebo that. So you say Gazebo world, I think is what it's called. So if you run a service that says ROS service call get world info or something like that, it'll return a list of all the objects that are in it. So in my case, it says, here's a flat planing Gazebo. It'll say, here's a robot called Ackermann vehicle, and here's a fire hydrant, which is something I just manually stuck in there as my marker for my transmitter. So then once you get that, then there was another command, you say ROS service call, and you'd have to say, I think the name of, you basically say get the model state, I think is what it's called, and then what vehicle, what you want. So I'd have a command that says ROS service call, get model state, Ackermann vehicle, and that returns back a pose message that tells me where the vehicle is located. And I'd run that again and say ROS service call, get model state, fire hydrant, and that would tell me where the other one is. So I could do that. Well, now in ROS2, I can't do that anymore. So apparently to get these services to work, I have to go back to those plugins where I said they split it all up. So I got to figure out which plugin it's in and then figure out how to run that. And it turns out that you try to run it, and says, oh, that's the wrong type. So I did some searching, and somebody says, oh, I had the same problem. You have to enclose it in some brackets saying namespace world or something, and then you put your thing in here to load it, and that's supposed to load it and fix it. But that's where I was at about 4 o'clock in the morning last night. So I gave up on that. I figured, well, it's running, and I figured I'd sit down with Al today and we just talk about whatever. And I didn't realize I was going to give this big presentation on the fly like this, or I could have had some more stuff figured out here. So just my impression of ROS2 is I realized it took me 5 to 8 years to learn ROS1 to the point where number one, I knew basically what I wanted to do. If I couldn't find it, I knew how to search for it. I knew where the documentation was to find it. Well, now starting with ROS2, I'm basically starting over again, trying to figure out, where is all this stuff located and what are the concepts. And I go through lots of YouTube videos and lots of people's blogs, and I'm slowly absorbing how this stuff works. I'm slowly absorbing how the launch files work. And I'm getting to the point where, I try it, it doesn't work, but it doesn't take me more than say an hour to track down one simple thing to fix it. So that's kind of where I'm at on that. That's where I'm at in my journey to do ROS2, and by next week I might have some more information on how things are going or where we're going with everything. So other than that, I could say, well, does anybody else have anything? But since I'm the only one on the meeting, I guess nobody else has anything. I like 2 weeks ago they had that presentation on the what is it, RSSC, Robotics Society of Southern California. They had a presentation, and the guy that maintains Navigation 2, the Steve Macenski, came on and presented his slideshow talking about what is Nav 2 and how do we change it from Nav 1 and all the new features it's got. And that was on their meeting, and that was recorded on they recorded and put that out on YouTube, and now that's available. And when I post this, I'll put that in the comment section telling you where that is. And then the Home Brew Robotics, I can put a link to where their website is. And I'd say within a few days to maybe a week or two, the thing from last night should be up there. So that's kind of my relationship to the outside world right now. So I'll post those on there when I build this. And I can't think if there's anything else that it's really earth-shattering that needs to come up right now. No, I guess that's it. So I guess I will sign off if I can figure out how to do this. Uh-oh.